Today, we're going to look at one of the most important questions anyone considering solar eventually asks. How long do solar panels actually last? Because if you're going to invest in a system that powers your home, your cabin, or an off-grid setup, you don't just want to know if it works today. You want to know how it performs after 5 years, 10 years, 20 years, and beyond. The answer is both encouraging and nuanced. So let's break it down in a realistic way, based on how solar panels behave in the real world over time. First, the simple answer. Solar panels typically last 25 to 30 years, and sometimes even longer. But that doesn't mean they suddenly stop working after 25 years. What actually happens is that their performance gradually declines over time. They still produce electricity, but they produce less of it compared to when they were new. So the real question isn't do they last? It's how much do they degrade, and when does that matter? Most modern solar panels are designed with a slow degradation rate of about 0.3% to 0.8% per year, depending on quality and environmental conditions. That means after 10 years, you might still have around 90 to 95% of original output. 20 years, maybe around 80 to 90%. 25 years, often around 75 to 85%, or sometimes more for high-quality panels. These numbers vary, but the key idea is this: panels don't fail suddenly. Now, let's talk about what actually causes that decline, because this is where the real story is. Solar panels are exposed to the environment 24/7 for decades. Constant UV radiation, heat cycles, moisture, wind, dust, and physical stress. One of the biggest factors is UV exposure. Ultraviolet radiation slowly breaks down the protective materials that seal and insulate the solar cells. Then there's thermal cycling, the daily expansion and contraction. A panel heats up significantly during the day and cools down at night. Multiply that by thousands of cycles, and you get tiny amounts of stress building up inside. This can contribute to microcracks or weakening connections. Another major factor is moisture ingress. Even though panels are sealed, no seal lasts perfectly forever, especially in humid or coastal environments. Microcracks can form during manufacturing, transport, or installation. You usually can't see them, but they can reduce performance by interrupting electricity flow. Even with all of that happening slowly, solar panels are still considered one of the most durable energy technologies available today. There are no moving parts in a standard panel. Less mechanical wear means fewer failure points compared to most other energy systems. That's why manufacturers offer long warranties, typically 10 to 15 years for workmanship and 25 years for performance guarantees. Now, let's talk about what actually ends a solar panel's life in practice. In most cases, panels don't suddenly die. First, slow efficiency loss reaches a point where it's no longer useful. It doesn't produce enough energy to justify its space. Second, external damage occurs, such as severe weather, physical impact, or long-term environmental exposure that causes visible failure. Third, system upgrades make older panels obsolete. Newer panels are more efficient, so older ones get replaced because they are less productive. Now let's connect this to real-world usage, especially off-grid systems, because this is where a lifespan really matters. In a grid-tied home, degradation is usually not a big issue. If your panels lose efficiency, you simply draw a bit more from the grid. But in off-grid systems, degradation matters more. Experienced designers always plan extra capacity for long-term decline. Solar panels are actually one of the longest-lasting parts of a setup. Other components will fail or need replacement before the panels do. Batteries often last 5 to 15 years. Inverters may last 10 to 15 years. Wiring and hardware can also degrade over time. So while panels can last 25 to 30 plus years, the system around them usually goes through multiple upgrades during that time. Now, let's talk about environmental differences. In hot climates, panels experience more thermal stress, which can slightly increase degradation rates. In cold climates, you may have less thermal stress but more snow load and freeze-thaw cycles. Coastal environments face salt and humidity. In dusty environments, reduced performance from dirt buildup can also create long-term efficiency issues if not maintained. Now let's bring it all together. Solar panels are one of the most durable and long-lasting energy technologies available today. They don't have moving parts, they degrade slowly, and they can reliably produce electricity for decades. But they are not permanent. So when people ask, how long do solar panels last? The most accurate answer is this: they last long enough to make them one of the most cost-effective long-term energy investments available. And the real key is how well your system is designed to handle that slow, inevitable change over time. Because solar isn't just about starting strong, it's about staying reliable decades later. And if you want more deep, real-world breakdowns like this on solar systems and off-grid living, make sure to subscribe to Off Grid Life Tech.